We've already come to the end of this MOOC, and we would like to summarize and put things into perspective in this final lecture. The MOOC started off with the question why? Why do we need change? Why should we develop a bio-based and circular economy? And why should we develop novel technology for bio-based products? And why should we educate people in this field? There are many reasons, like worries about climate change and energy security, increasing oil prices, securing the needs of a growing world population. We covered this in the first week, where we introduced you to the topic of our MOOC. Technical and sustainability aspects came together in the presentation of Dr. Chris Padden from Emeris, a California-based biotech company who told you about their work on semi-synthetic artemisinin production. This is a beautiful example of bioprocess development for a bio-based product with a clear social sustainability component. In week 2, Professor Sef Heine introduced the technology options that microorganisms provide us with. Microorganisms are capable of synthesizing a large range of compounds, and nowadays it's possible to improve microorganisms for bioprocess development. Moreover, Professor Heine showed you what microorganisms need and how you can quantify what they consume and produce. You can actually model and predict biological processes, a concept used throughout this MOOC. In our best practice that week, Mark van Loosdrecht, professor in environmental biotechnology at our department, introduced the use of mixed microbial cultures to make useful products like polyhydroxyalkanoates, plastics, or alginate. He showed us that we only know a fraction of microbial diversity out there, and there is a lot to explore. This example illustrates nature's immense possibilities and is a notable illustration of converting waste to resources. In the third week, Professor Heine further elaborated on the quantification of biological systems. By using the black box model, only a limited amount of information is needed to calculate the key parameters and make reasonable estimations on your process. This is achieved by using a single limiting nutrient. By this approach, you can calculate all rates and have only one free variable, such as the specific growth rate, mu. As explained, there's a clear difference between energy generating and energy consuming products, so it's vital that you know what kind of product you're dealing with. In case you miss parameters, Professor Heine explained to you what kind of experiments you have to perform to be able to estimate these parameters. You applied this black box approach in the PDO case. Finally, Professor Luis Cortés, Vice Rector International Relations of the University of Campinas, gave an historical perspective on bioethanol production from sugarcane. This biofuel is very important for Brazil. Although the industry is already very mature, there are still many challenges and possibilities in this. When you know the principal characteristics of your fermentation, it's time to go to the large scale. And this is what Professor Henk Noorman covered in week 4. We're no longer working at lab scale, but a few orders of magnitude larger, there are of course very different considerations. Suddenly, you have to worry about transport issues, heat removal and mixing. And what kind of bioreactor are you going to choose? A stir tank, an airlift loop reactor, or a bubble column? Another vital choice is how you will operate your reactor. Will you use batch, fat batch, or continuous operation? And Professor Noorman introduced you to the main differences, advantages, and disadvantages of reactors and modes of operations, so you can make a well-balanced choice for your own bioprocess. In the design process, the large-scale practice should be taken into account as early as possible. You have to design your process with the target end in mind. And Professor Noorman showed you options to mimic the large-scale situation in the lab. This concept of starting with the final target in mind was clearly illustrated in the succinic acid case that Dr. Mikkel Jansen, senior scientist at DSM, presented. Since succinic acid is a bulk product, it's essential that the process is cost competitive. Moreover, in the process design, sustainability was taken into account from the very, very beginning. Although we spent quite some time on designing the fermentation, Our final aim is an integrated bioprocess, which involves many more design steps. And this was the subject of week 5, where Professor Luc van der Wiele took you through the entire process, from feedstock to end product. Before fermentation, you need to prepare your feedstock, the so-called upstream processing. Especially in the case of lignocellulosic feedstocks, this is a highly important step, and many steps are involved. In addition, the stream leaving the fermenter should be processed into a pure and specified product stream, the so-called downstream processing. The key approach introduced in the MOOC is to start with a conceptual design using mass and energy balances, and a flowsheeting program like SuperPro Designer, which was actually used in the case study, will allow you to simulate and optimize the various flows going in and out of the fermenter. You will always have to find a balance between operational expenditures, capital expenditures, and process sustainability for an optimal bioprocess. The best practice was presented by Dr. Henk Jonkes, who applies biotechnology for building engineering. His limestone-producing bacteria can heal damaged concrete. Since concrete is the most used construction material in the world, there's no need to convince you of the huge relevance of this work. In the last week, we shifted focus from engineering the process to process evaluation and sustainability. And to build a sustainable business case, the 3 Ps, profit, planet and people, need to be assessed. Firstly, the economics have to be favorable. And Professor Patricia Osserweijer told you how you can perform an economic evaluation. An advantage of bio-based processes is that, in general, they are greener than their fossil-based equivalent. By performing a life cycle assessment, you can actually quantify the environmental impacts of a given process and compare it with possible alternatives. This allows you to identify sub-processes which need to be improved for further development. It's important to see the impact on people in local settings. Therefore, important issues for further social improvement were identified. You've seen that such evaluation helps to identify the best options for process improvement in your design and how changes to the strain or change in feedstock and process technology matters. That is why these assessments need to be integrated in the whole process development. In the best practices from Brazil, Professor Joachim Zeebra shows how the process for making bioethanol from sugarcane runs. And in addition, Professor Arnoldo Walter discusses the sustainability of first-generation bioethanol in Brazil. Throughout this MOOC, you've also worked on a case study, and we selected bio-based production of 1,3-propanediol, PDO, for this. This is a product which is already produced via biotechnology and which can serve as a platform chemical. Therewith, it's a key example of a bio-based bulk product. The case study allows you to apply the theory of the lectures in real life, and in this way you could practice the concepts and calculations all the way from microbial metabolism to the full-scale industrial process. We hope that this case study convinced you even more of the possibilities of technology for bio-based products, and that you now feel comfortable with the quantification and assessment of microbial processes, which is an essential skill for a bioprocess engineer. We started this MOOC with the question, why develop a bio-based economy? The answer, because we have to, and we can, using the technology you learned to apply it in this MOOC. Now finally, a personal note. For our department, it was the first MOOC. Actually, it was our first large online education activity, and it was a great experience for us. We learned many aspects of online didactics, discovered possibilities like the animations we really liked, but also things we would like to expand on for our next run. We hope this was also a great learning experience for you. We want to thank you, all of you, for your active participation, your input and hard work. Perhaps we'll meet again in Delft or anywhere else in the world. Good luck realizing your contribution to a sustainable future.